Imagine for a moment that some of the really fundamental things we think we know about the universe, well, they might not be quite as solid as we believe.
Yeah.
Things you learn in school, the basis for, tons of our technology. What if some key experiments, some over 100 years old, actually hinted at problems?
Problems with our understanding of space, time, even the Earth's motion itself.
Exactly. Welcome, everyone, to the deep dive.
This is where we take material listeners send in and really get into the ideas presented. And today, we're diving into fundamental physics.
Yeah, looking at some classic experiments, but maybe through a lens you haven't seen before, based on the audio sources a listener shared with us.
These sources challenge some big ideas at the heliocentric model, for one, the Earth going around the sun.
And they even take aim at aspects of Einstein's relativity, all based on interpretations of these experiments.
So our mission today is really to unpack what these sources say about experiments like Michelson-Morley, Sagnac, Airy's failure. Quite a list, actually.
We'll focus on how the source material uses these experiments to make its case, particularly about the ether and whether the Earth is actually moving. We're following the logic presented in the sources.
Okay, so let's start with this idea of the ether. Late 19th century, this was like standard physics.
Right. The idea wasn't that space is empty. It was filled with this invisible stuff, the luminiferous ether.
And this ether was supposed to be the medium for light. Like sound needs air or ripples need water. Light waves needed the ether to travel.
That's the concept. And if light's a wave, well, something's got to be waving.
The ether was it. Invisible, maybe, but absolutely essential in their view. And this tied directly into thinking about the Earth.
Because if the Earth is orbiting the sun, it must be moving through this ether.
Which leads us straight to the Michelson-Morley experiment in 1887, a really famous setup.
Super clever, yeah. Its whole purpose was to detect this motion, the Earth moving through the ether.
They expected to find an ether wind, basically. Like sticking your hand out of a moving car window, you feel the wind, even if the air isn't moving relative to the ground.
So the Earth moving through the stationary ether should create a detectable effect on light speed.
They used an interferometer. It splits a light beam, sends the two halves off at right angles, bounces them off mirrors, and then brings them back together.
And the prediction was simple. The beam traveling with and against this supposed ether wind should take a different amount of time than the beam traveling across it.
Like swimming upstream and downstream versus swimming across the river. Different travel times over the same distance, right?
But that's not what they found. Not really.
No. This is the famous null result. Now, they did measure some small effect, maybe 1 to 10 kilometers per second, according to the source.
But they were expecting something much bigger, closer to 30 kilometers per second, based on the Earth's orbital speed.
So compared to what they were looking for, it was basically nothing. No significant ether wind detected.
And this null result just threw a massive wrench in the works.
Yeah, our source really emphasizes this point. It presented physics with a dilemma.
Two main options, right? Either the ether, this medium for light, doesn't exist as they thought,
Or the Earth isn't actually moving through it, which implies a stationary Earth.
a direct challenge to the Copernican model.
Now, one attempt to fix this, which our source is quite critical of, was the Fitzgerald-Lorentz contraction.
Right, the idea that maybe the measuring equipment itself physically shortened in the direction it was moving through the ether.
Exactly. It would sort of mathematically cancel out the expected time difference.
But the source points out pretty strongly that there was no evidence whatsoever for this physical contraction.
Yeah, it portrays it as a kind of mathematical trick, an ad hoc hypothesis, they call it, designed purely to avoid concluding the Earth was stationary.
Just patching up the theory to fit the unexpected result?
While the contraction was a genuine proposal at the time, it's true that mainstream physics eventually went in a very different direction.
And that direction was Einstein, early 20th century.
Right. Special relativity, 1905, then general relativity. Einstein basically said, we don't need the ether.
He proposed that the speed of light in a vacuum is constant for everyone, no matter how they're moving. It just is. No ether required.
This neatly explained the Michelson-Morley result without needing contractions or a stationary Earth.
But the source material we're looking at really pushes back against this.
Hard.
Yeah.
It brings up Professor Herbert Dingle, who had this great quote.
The grin without the Cheshire Cat one.
That's the one. Dingle argued you can't just have the properties of a medium like wave propagation without the medium itself. Light waves need something to wave in, just like water waves need water.
It's an intuitive argument. The source claims abolishing the ether is fundamentally illogical from a wave perspective. Of course, mainstream physics uses the concept of self-propagating electromagnetic fields now, not a mechanical ether.
But sticking with the source's line of argument, this brings us to another key experiment. Sagnac, 1913.
Okay, so Sagnac, what was the setup there?
Sagnac took a beam of light, split it, sent the two beams in opposite directions around a path on a turntable, and then recombined them.
And looked for interference fringes, like in Michelson-Morley.
Exactly. When the table was still, stable fringes.
Mm.
But when he rotated the turntable,
The fringes shifted.
they shifted. And the interpretation in our source is that this shift proves the ether exists.
How so?
The argument is, light speed is constant relative to the stationary ether. When the table rotates, one beam is going slightly with the rotation relative to the ether path, the other slightly against. This creates a tiny path difference through the ether.
Which causes the fringe shift. Okay, I see the logic presented there.
And the source claims this directly contradicts relativity. It argues that according to relativity, since the speed of light is constant for all observers and there's no absolute ether frame, the rotation alone shouldn't cause a shift like this.
So observed shift equals proof of ether, failure of relativity. That's the source's conclusion.
It's important to add here, though, that mainstream physics does account for the Sagnac effect within relativity. It's explained using the way space-time geometry works in rotating frames, not by invoking ether. But the source presents it as a clear contradiction.
The source also mentions, and this is quite interesting, that the Sagnac effect isn't just theoretical, it's used in real technology.
Yeah, like in ring laser gyroscopes for navigation in airplanes. The effect itself is measurable and utilized.
So the phenomenon is real, the debate is purely about the why. Ether or relativity.
According to the source, absolutely.
Mm.
And it doesn't stop there. It lists other experiments backing the stationary Earth idea.
Like James Bradley's work from way back in the 1700s on stellar aberration, the source claims this shows the ether isn't dragged along by Earth.
Then Michelson did another experiment with Gale in 1925. The interpretation offered is that this detected the ether rotating relative to the Earth's surface once every 24 hours.
And then there's Airy's failure from 1871.
Right. George Airy used a water-filled telescope. Our source, citing Dr. Neville Thomas Jones, claims Airy's results actually show the Earth is stationary and the stars are moving, carried by the ether.
It also briefly mentions Muscart, Dudras, Teuton Noble, a whole suite of experiments allegedly consistent with a stationary Earth.
And the big takeaway from the source is this really bold claim. There is not a single experiment that proves that the Earth moves.
Wow. Okay, so all these results point one way, according to the source, and the idea of a moving Earth is just theory, assumption.
That's the assertion, that the experimental evidence points toward a stationary Earth in an ether, and that science chose to ignore this.
Which obviously flies in the face of, well, centuries of established astronomy and physics.
A very significant departure, yes, which leads the source into claims of a cover-up.
It uses the term virtual blackout regarding these experiments in science education.
Yeah, there's an anecdote about a Dr. Malcolm Baldwin asking Christian physicists about them, and apparently they didn't know them.
And a quote from another physicist saying he worked for 30 years before even hearing about the Sagnac experiment.
The source argues this isn't just an oversight. It suggests it's deliberate suppression.
To protect what it calls the godless scientific community's core belief in Copernicus, and by extension, evolution, is that the connection they make?
That's the connection drawn in the source material, yes. A very strong claim about motivation.
It paints the reaction to Michelson-Morley's null result as almost panic.
Desperation is the word used, leading to what the source calls the ridiculous, unsupported Fitzgerald-Lorentz contraction.
It even mentions there was debate about whether it was a contraction or an expansion initially, suggesting it wasn't based on solid ground.
Again, positioning it as a way to avoid the stationary Earth conclusion rather than a genuine physical insight at the time. Of course, relativity provided a different path forward later.
But the source remains highly critical of that path, specifically Einstein's role.
Yes, the argument is that Einstein simply abolished the ether without proof just because it was convenient for explaining Michelson-Morley.
Back to the grin without the cat idea. You can't just wave away the need for a medium for light waves.
That's the recurring point. And they bring in Nikola Tesla, quoting him as warning against theory and math replacing actual experiments.
Then it focuses quite a bit on Professor Herbert Dingle again.
Who started as a supporter of relativity, apparently, but then turned into a major critic.
Why the change?
He claimed to have found a fundamental paradox within special relativity related to the reciprocity of time dilation between moving observers. And, the source alleges, he was denied publication for his criticisms.
So Dingle's argument as presented here is that math can essentially mislead you.
Yes, he used an analogy. Something about defining a glass as half empty, E, and half full, F, and through mathematical steps concluding EF, which is absurd.
Yeah.
His point was that math can dress up falsehoods.
And he felt relativity did this, using complex math and thought experiments to bedazzle people.
That's the characterization, that physicists kind of surrender their intelligence to mathematicians after general relativity seemed successful in 1919.
The source even uses an Einstein quote about fantasy being important in his thinking.
To imply relativity is more like mysticism supported only by mathematical models. It calls it akin to a religious cult, intolerant of criticism.
Strong words. It also mentions others critical of relativity like Charles Lane Poor, Dr. Lewis Essen, Lord Rutherford.
Yes, presenting a picture that criticism existed but was perhaps marginalized. The source concludes this section by restating Dingle's final position, that after years of study, he found relativity invalid due to unresolved paradoxes.
Okay, so let's try and wrap up what we've unpacked from this source material today.
We started with the ether concept and the shock of the Michelson-Morley null result.
Then how Einstein's relativity provided a solution by getting rid of the ether, a mood the source heavily contests.
We looked at the Signac experiment, which the source interprets as clear evidence for the ether and against relativity.
Plus, a whole range of other experiments the source claims point towards a stationary Earth, contradicting the mainstream view.
And finally, the source's arguments about a scientific cover-up and its detailed critique of relativity, leaning heavily on the later work of Professor Dingle.
It's definitely complex stuff and clearly involves interpretations that are way outside the scientific mainstream.
Absolutely. Which leads to a provocative thought for you, the listener.
Yeah, think about this. Given the experiments discussed and the interpretations offered in this source material, how does it make you reconsider what we accept as fundamental physics?
Does it challenge your understanding? Reinforce it? Does it make you question how scientific consensus actually forms?
What are the implications if, just hypothetically, the established story isn't the whole story?
We really encourage you, if this has sparked your interest, to look into these experiments yourself. Dig into the history, find different perspectives.
Seek out diverse sources and really wrestle with the information to form your own conclusions.
Thanks for joining us for this deep dive into some genuinely thought-provoking and maybe controversial ideas.
We'll see you next time on The Deep Dive.